Hello, everyone, and good morning, good afternoon, or good evening, depending on where you're tuning in from. My name is Jacob Lee, and I'm a software engineer at LangChain. I'm excited to be presenting at Neon Developer Days, and I'll be talking a bit about querying Postgres databases with natural language. And a quick aside before I get started. If you're not already familiar with LangChain, we make it easy to build context-aware reasoning applications. And more concretely, you can think of what LangChain offers as a four-layer cake that helps you create and deploy large language model-powered applications. We're most well known for open source libraries of models such as document loaders, vector stores, prompts, and LLM wrappers that provide common interfaces for various tasks around orchestration. These pieces parse, format, and retrieve data from various sources to present as context to an LLM. Our open source frameworks, available in JavaScript and Python, also include useful ways of prompting and chaining different model calls together, hence the name, to build sophisticated and powerful applications using expression language. And finally, we provide tools such as LangSmith that help debug and evaluate LLM apps, tools such as LangServe that help with pushing apps to production, as well as various templates that show off LLM use cases that you can apply to your own projects. So, first off, a bit of framing. Why do we want to query SQL with natural language? Well, though most of you are probably quite familiar with writing queries, SQL is still a skill that takes some time to learn, particularly as queries become more complex. Furthermore, people who do know basic SQL in your organization might know a bit generally about what your database contains, but may not always be familiar with the specific fields and schema in your particular database. So empowering non-analysts to have some insights into data that's behind this knowledge threshold has the potential to save engineers and data scientists time in creating complex and bespoke dashboards. And given many popular LLMs already have SQL queries in their training data, we have some powerful tools ready-made to make it work. So our strategy will be to use a form of Retrieval Augmented Generation, or RAG for short. RAG is a general technique for guiding LLM generations. If you think of a continuum where on one end you have pure retrieval, like going into Google and querying for data, or manually writing a SQL query, and on the other end, you have pure generation via LLM, which would be the equivalent of opening ChatGPT and simply asking for the data you need. Retrieval augmented generation sits in the middle, where you take the best of both worlds and take data related to your query, pass it to the LLM to give it context on your unique task and situation. Specifically for SQL, you might start with a question like, who works here? You could find the answer by querying your database, but this requires SQL knowledge, schema knowledge, and some formatting at the end to make it presentable to an end user. They're not going to want to parse through rows. Our task then for allowing natural language interactions with our SQL database is twofold. We first need to find a way to map a natural language input, like who works here, to a SQL query that will return the correct information. And second, we need to pass the queried rows into an LLM to synthesize as a final natural language output to the user. The latter part is somewhat simpler, so we'll mostly be focusing on the first part of the problem, generating a SQL query via LLM. So now that we've identified the problem, where do we begin? And, well, as everyone knows, LLMs are magic and can do literally anything, so why not try straight up asking the LLM and directly prompting it with, generate me a Postgres query that finds the first and last names of everyone who works here. And the result is actually surprisingly not too bad. However, it did assume that the table name was employees with the trailing S, while our sample database, the popular Chinook demo database, has a table called employee, singular. This is an understandable mistake, given that we haven't told the LLM anything about our database schema. And there's also a bunch of other output that we'll need to parse out at the end. That's to find the first and last names of everyone, etc., and the trailing bit where it's this query selects the first and last name, etc. We just want the query itself. So let's take a look at how we solve the first problem. As I mentioned earlier, LLMs are trained on a large set of data, including code and SQL queries. So they already have Postgres syntax internalized, which is quite helpful since we don't need to explain to the LLM how to craft a Postgres query. And then Raj Kumar et al. Discovered that actually pretending to create each relevant table with literal create table syntax, and then giving an example of some rows using a small select query, generally similar to few-shotting, a technique called few-shotting rather, gives noticeably boosted performance over other methods, such as just directly pasting your raw schema to the prompt. And for the second problem, formatting our output, we use a neat trick. We ask the LLM to structure its output in a format that actually doesn't have the query as the last step. And then we pass SQL result, the next token in the output that we'd expect, as something called a stop sequence that, as the name implies, flags to the LLM to stop generating once it would have generated that given token. We then end our prompt with the beginning of the output structure we requested. The reason this works is that LLMs, even those tuned to chat settings, such as the famous GPT-4, are essentially fancy prediction engines that pick the most likely next token given the context. By ending our prompt with the start of the output structure, we hint to the LLM that it should complete the next line, which we have already told it should be SQL query earlier in our prompt, followed by a generated SQL query. After generating the query, it will try to generate the token's SQL result, but since we've passed that as a stop sequence, the LLM will halt there, and we can extract just the generated query. Though chat models can do this, I've chosen to use a text prediction variant of GPT 3.5 Turbo, called GPT 3.5 Turbo Instruct, that is more tuned to this style of prompting. So, putting it all together, we end up with the following prompt. I've added a few more lines to try to guard against large outputs and hallucinations, and you can check out the prompt and pull it for yourself from the LangChain prompt hub using the link at the bottom of the slide. And there's actually one more piece to call out about the prompt, and that's the initial line. You are a Postgres expert. Though it sounds a bit silly, this actually has a noticeable impact on the quality of the final generation. And to understand this intuitively, LLMs are trained on the sum of all human knowledge, including very bad SQL writing blog posts. Including a line at the start of this prompt, at the start of your prompt, keys the LLM onto the good parts of its training data set that you do want to use, like the parts that know how to write good Postgres queries. It's a simple trick, but one worth highlighting. All right, great. We've got a way to generate our SQL query. Now, of course, our next step is to run it. And given that many of you in the audience are probably experienced SQL developers, if you didn't have an immediate, visceral reaction to that statement, I'm very, very disappointed in you. Now, depending on what you're building, you may not have control over the questions your end user will ask your app. Think of it like sanitizing inputs, except the entire query is, in fact, your input. And you should expect and guard against the LLM generating queries like drop tables or update customers, set email, you stink at smelly.com. And you should use this as much caution as you possibly can. Setting a special role for LLM queries and strongly considering making it read-only is a great start, as that way you'll guard against dangerous mutations or deletions. And going further and restricting that role to specific tables is also good practice, since the LLM could have a lucky hallucination and guess a sensitive table or field name, even if you don't pass it in as context schema. You might also consider using a separate database or branch to ensure that if large queries do get generated, they don't excessively consume resources from critical prod flows. If you do need to allow insert, update, or delete access, make sure you set your permissions carefully and don't just allow inputs or deletions to arbitrary tables. And finally, though it's out of scope for this talk, you could also try to do analysis of generated queries before running them on the database. Okay, so hopefully that scared you a little bit, but not too much. After all, this is still pretty cool. So the final piece of query generation I can talk about is using a lower level OpenAI parameter called logit bias. And basically, inputs the LLM are encoded and are then processed as tokens. It's a bit more technical, but OpenAI actually allows you to manually tune the frequencies of those specific tokens. Negative 100 values never appear, while passing a value of 100 makes the token exclusively appears. Not terribly useful. And one other thing to watch out for here is that tokens are actually case sensitive. So something like the with a capital T will actually tokenize differently from the with a lowercase t. Now here's a concrete example of how this can be useful. With the sample Chinook database I prepared for the demo app, asking, what are some good movies? We'll surprisingly restrict outputted movies to the action and adventure categories, as you can see in the generated SQL below. There's a join there, and you wouldn't expect it to necessarily only generate action and adventure movies, but it seems like that's what the LLM and feels are good movies. And it's, again, hallucinations, arbitrary, anything can happen or be generated here. Adding a positive bias towards the token drama will make the LLM generate a query that filters on drama, while still allowing more specific queries that you'd actually want different categories. So what are some good action movies, for example, would still work and generate good outcomes and good queries there. And a word of caution here. While this is an interesting tool in your kit, it's best not to treat it as a substitute for security measures and only use it for nudging outputs. So for example, tokens are case sensitive, and as I mentioned earlier, and furthermore, putting a space before most words will cause them to tokenize differently. You can see in the example to the right that I've put delete twice in caps and lowercase delete once, and resulted in 3 different tokens. So while you might think you're safe by passing capital delete as a forbidden token, the LLM could still generate space delete or some case insensitive version, such as capital D, all lowercase delete. And given an input that asks it to drop tables or delete from a table, the bias is already so strong for the LLM to generate a query with that token that it's just not reliable to ban specific SQL behavior. It'll try to find a way around it or generate nonsense in the best case. So you should think of logit bias as a similar spirit to prompting in that it'll guide the LLM's output and ideally generate better outputs for tokens you do want, but relying on it as a single measure to ban bad behavior is a losing battle. Okay, and now I've prepared a demo app built on a NeonDB hosted version of the popular Chinook demo database, which mocks a digital media store and has tables for artists, albums, media tracks, invoices, and customers. It's hosted live as a Vercel Next.js app, and I'll go through it a little bit right now. Okay, so switching to Chrome here, I have a talk to SQL with LangChain.js app hosted on Vercel. It's actually querying a serverless NeonDB Postgres instance running the Chinook demo database behind the scenes. And again, that's the database simulating a media record store with various tables for artists, albums, media tracks, invoices, customers. So let's just try querying something. Who works here? As you saw earlier, there's already an employee table, so I'd expect some kind of select query that looks over employees. And let's see, generated a query that looks pretty much what I expect. The employees who work here are Andrew Adams, Nancy Edwards, Jane Peacock, Margaret Park, etc. And I can actually go into LangSmith and see what this trace looks like. So I'll go in now. And I can see that, yeah, this is what I expect. The outputs I saw from the app there. But I do see 1 or 2 interesting things. First of all, it did ignore the query for most 5 results using the limit clause as per Postgres here. Example of how you can't necessarily exclusively rely on prompting, even though it can be helpful for guiding outputs. You can't exclusively rely on prompting to prevent bad outputs or bad queries in this case. But you can see the rest of the prompt, the expert prompting, which I showed off here. You are a Postgres expert, which is quite helpful. Some of the tables that are few shotted in, so create table, public actor, exactly how you create the table if you were generating it yourself. And yeah, if you shot it with select queries, and then scrolling down farther, there's quite a lot of information here. In production, you may not want to give it, you may not even want to pass all these tables in as context, but just for the demo purposes, so we can sort of show everything, I'm doing it here. And then you can see the SQL query that gets generated. Cool. So this is a very simple example. Let's try a more complicated one. So I think I showed earlier, there's no chat history for this, by the way, yet, but should theoretically be possible with smart prompting. And I could try something like what movies are good. And let's see what happens. So it's going to go through all the steps, generate. And yeah, I see the movies Airplane Sierra, Amadeus Holy, American Circus, etc. are good options to watch as action or comedy. I guess the LLM has its own concept of taste, but you can see it does actually an inner join on category and looks specifically for action or comedy movies, which is kind of cool. And it does, in this case, get the limit as 5. So yeah, let's look at this in LangSmith. I'll go back to my dashboard here. I can see the new query here. And yeah, I can see, again, same prompt here and the outputted query below, which is exactly what I saw in the initial database, or sorry, the initial output from the app there. So I think one thing to call out here is perhaps, let's say, okay, it's a little bit weird that, the only good movies are not, there are good movies outside of action or comedy movies. So let's say, yeah, we want to figure out why it's only generating action in comedy movies. And I think a common first step for this is to edit the prompt and update it so that the LLM is more inclined to generate maybe movies from other categories. So I can actually go into, LangSmith has a playground feature where you can actually go in and look at the prompts that sparked and kicked off specific runs. So I can see exactly the same prompt I saw before. I can see the model I used to generate, so I could try different models if I want to. For now, I'll just stick with GPT 3.5 Turbo Instruct. I can see different parameters and edit them. So temperature is a common one. Higher temperature is more creativity. Too high, as you'll see in a minute there. Get myself out of the way there. You get kind of garbage if you put it all the way up to 2. Yeah, you get kind of craziness. So you don't want to set it too high. I think for generally structured outputs, setting it low is quite a bit more useful. And then you can also see the stop sequence that I previously mentioned. So let's try updating the prompt to say, pay close attention to the movies, or the category of movie you return. You should return mostly drama movies. Cool. And if I run it now, let's see what I get. Okay, cool. So yeah, this time it didn't actually return any category-based movie, but instead rated on PG versus G. So I guess good in this case was taken to mean family-friendly. But how about return? The only good movies are drama movies. Okay, and this time I get, in response to the question, what movies are good, a SQL query that restricts only good movies to drama, category name drama. Cool, so this is an example of how LangSmith can be helpful to tweak prompts and generally get your LLM apps generating what you want them to. The below link has a representative LangSmith trace that allows you to see the various inputs and outputs of each step. The project I looked at earlier wasn't publicly available, but you can go to the link at the bottom of the slide there to go and poke around the various steps and inputs and outputs at your leisure. So LangSmith is currently in open beta, but if you'd like to try it out, you can sign up with LangSmith_partner_2023, all lowercase. And that'll let you sign up and immediately start sending traces to projects. And that's it. Thank you very much for listening, and I really hope you enjoyed my talk. If you'd like to keep in touch, you can follow me at Hakubu on X, formerly Twitter, and follow LangChain at LangChain AI for more goodies. I've also included links for both the live demo app, the source code, and all the technologies used in it below. I hope you enjoy the rest of the conference.